This is a problem with conservation of momentum. We have a single person on frictionless horizontal ice moving off to the right at 1.23 meters per second, and the person has a mass of 50 grams. The person is carrying a 4-kilogram rock and decides to throw this rock behind them. The speed of the rock is 3 meters per second. The rock does not move horizontally away from the person, but it's inclined up at an angle of 36 degrees above the horizontal. We want to determine the velocity of the person after the rock is tossed out. Well, if we make a little sketch of this, we've got the person traveling off to the right, carrying the rock, and then later the person has thrown the rock. The rock, again, the speed of 3 meters per second is upward at 36 degrees from the horizontal. We want to know what the final velocity is. So this is a situation where we can apply conservation of momentum. Because the ice is frictionless, there is no horizontal external force on the person, and we can assume momentum is conserved. This internal force of the person throwing the rock does not disqualify us from using conservation momentum. Internal forces are okay. So let's reveal a little bit of the calculation. Our concept is momentum final equals momentum initial. The mass of the person and the velocity final plus mass of the rock and velocity in the x direction of the rock. We cannot use 3 meters per second here. We have to restrict ourselves to just the horizontal component of the velocity. This will equal the initial momentum, the mass of the person plus rock. Would be a better way to label that. In this initial picture, it's 54 kilograms, not just 50. So mass of the person plus the rock is what we have initially, moving off to the right at 1.23 meters per second. Well, let's discuss a little bit this rock. The rock, if I draw here a right triangle with 3 meters per second as the hypotenuse, 36 degree angled up, the number we need, this velocity in the x direction, is adjacent to the 36 degree angle. So we need to use the cosine function multiplied by the hypotenuse. That will give us the value of this adjacent side. So 50 kilograms, the person after the rock is thrown, the velocity of the person, plus 4 kilograms, and now I assign the correct plus or minus sign to the velocity of the rock. It's off to the left, so we give it a negative. Off to the right is my positive direction in this problem. So the rock's component in the x direction is a negative number, negative 3, cosine of 36 degrees. And then I almost messed up here, but before the rock is thrown, the system has a mass of 54 kilograms, moving off to the right at 1.23 meters per second. Again, this picture, 50 kilograms for the person, 4 kilograms for the rock. Both of them have a velocity to the right of plus 1.23 meters per second. A little bit more math here. Multiplying our 4 times minus 3 and cosine 36 degrees. And you should get your calculator and verify these numbers. And here 54 times 1.23 gives us the 66.42. Add 9.708 to both sides and then divide by 50 after you've done this addition. And hopefully you'll agree with me that the velocity is 1.52 meters per second. This is the person's velocity. Is this reasonable that it is larger than 1.23? Yes, it is reasonable. The momentum here has to be more positive than what we had before because we have a negative for the momentum of the rock. So it is reasonable that we get a higher velocity here times the 50 kilograms for that person. So there we are. That's the end of this calculation. Conservation momentum can be applied as long as your velocities are parallel, and make sure you keep track of plus and minus signs on the velocities. Choose either direction to be positive, either to the right or to the left. draw some pictures, make sure you understand what the masses are for each calculation. For more of these physics and astronomy tutorials, try these websites, and nothing to sign up for or buy here. It's all free, and you can see listings of my YouTube videos. And be sure to ask your instructor if you're having questions on this.